In this next lesson, we're going to be learning about quadratic equations. Quadratic equations have the standard form of ax squared plus bx plus c equals 0. We've only been working with equations so far this year that had x's in them, like x to the first when we were solving them, and now we're going to have ones that have an x squared in them. In this form, the ax squared plus bx plus c equals 0, the a is still the leading coefficient. And actually for now, all the questions that we do today are going to have the b be equal to 0, so that we just end up with ax squared plus c. When b is some value other than 0, things get a little bit more complicated, and we will come back to that in a later lesson. For now though, when we have an equation that looks like ax squared plus c equals 0, we're going to first try to get the x squared by itself by using inverse operations, and then remember that we recently learned that to undo a square, you use a square root. So we'll be taking the square root of both sides. Once we've isolated the x squared, we're going to have an equation that looks like x squared equals some number. And depending on what that number is, we might have different types of solutions. If that number is positive, so like if we end up with something like x squared equals 25, we're going to end up with two solutions. And the reason that is because there's two values that would make x squared equal 25 a true statement. So for example, if I'm asking what number times itself equals 25, there's two answers. I could either do 5 times 5 equals 25, or I could do -5 times -5 equals 25. Now, if I get the x squared by itself and I end up with something like x squared equals 0, then I'm only going to get one solution, because when you take the square root of both sides, the square root of 0 is just 0. If I end up with something like x squared equals -25, then there's no real solution, because there's no number times itself that would equal a negative number. If you do a positive number times a positive number, you get a positive number. And if you do a negative number times a negative number, you get a positive number. So at this point, we don't know any way of how to do a negative times a negative and end up with a negative, or a positive times a positive and end up with a negative. In Algebra 2, there is some further to learn here. Next, let's look at a few examples. All of these equations already have the x squared isolated. So all we need to do at this point is use the inverse operation to be able to get that x by itself. Remember, the way that you undo taking a square is to use a square root. So for all of these, our first step is going to be to take the square root of both sides. Now, when you take the square root of x squared, those undo each other. However, remember a moment ago we said that if I was looking for two numbers that multiplied together equal 25, I said there'd be two answers. There'd be 5 and -5. So actually, when you take the square root of x squared, you get two answers. You get positive and negative x. Just like in that sample problem earlier, we got +5 and -5. And then the square root of 4 is 2. And then basically what we're going to do here, you can think of this positive and negative x, think of it as a +1 and a -1, and it's like two separate problems. We're just trying to save some writing by putting it together, but what it really means is +1x equals 2 and -1x equals 2. And then to get the -1 over to the other side with an inverse operation, we would divide both sides by -1 and we'd get x equals -2. So here are our two answers where we've gotten a +2 and a -2. And again, we would usually do a little less writing, and we would write them as plus or minus 2. So that plus or minus is like a shortcut so that we don't have to write x equals 2 or x equals -2. It's a little bit less writing. All right, let's try the next one here. X squared equals 0. We're going to take the square root of both sides. the square root of x squared is plus or minus x. The square root of 0 is 0. And then I would divide both sides by +1 or -1, one at a time, because it's really two different equations. However, 0 doesn't have a sign, so 0 divided by -1 is still just 0. There's only one answer here. So if you get x squared equals 0, there's only going to be one answer. Okay, moving on, we've got x squared equals 32. We're going to take the square root of both sides. The square root of x squared is plus or minus x. The square root of 32, this one doesn't work out quite as nicely, so this is where we would have to use our prime factorizations to break this down. The prime factorization of 32 is 2 to the 5th, 2 times 2 times 2 times 2 times 2. Now, rather than writing that out, I'm going to break that into things that are in perfect squares. So 2 times 2 times 2 times 2, and then there's one extra 2 left over. And remember, using our product property, we're really just breaking this up into separate radical problems so that we can simplify the ones that are perfect squares. Remember that the square root of 2 squared is just 2. Square root of 2 squared is 2, and square root of 2 doesn't simplify, so we're going to leave that like that. Okay. And now we've got 2 times 2 times root 2, which is 4 root 2, and then think of that really, remember that's like two different equations. Positive x equals 4 root 2, which is already solved, and then negative x equals 4 root 2, in which case you divide both sides by -1, and you'd come up with x equals negative 4 root 2. So our two answers are positive and negative 4 root 2. All right, and then our last question, x squared equals -1. We'll take the square root of both sides. The square root of x squared is positive or negative x. The square root of -1. That's the problem. There's no two numbers times itself that equal a negative number. Not that we know how to work with at this time anyway. So this is undefined, and we're going to say no real solution.